Okay, so we are trying to do here some simple numericals of the module 5, which corresponds to the determinants. Okay, we'll go through that. So first what we have is, if a 4 by 4 matrix has determinant A equal to half, find determinant of 2A, determinant of minus A, determinant of A square, and a determinant of A inverse. So here determinant of 2A is 2 to the power of n. N is the size of the matrix, and that is 4 by 4. So therefore this is 4. 2 to the power of 4 is 16, multiplied by determinant of A. Determinant of A is given as half. So therefore it will turn out to be 8. Then determinant of minus A will be equal to minus 1 to the power n. N is 4 again, multiplied by determinant of A. Minus 1 to the power 4 will be again, the value which is, so to say, plus 1 only, because it is even power and determinant of A is half, and therefore it will be half. Determinant of A square will be equal to determinant of A whole square. So half square will give you 1 by 4. So really speaking, determinant of A square will be equal to determinant of A whole square, or one can say that it is equal to determinant of A and determinant of A. Okay, then determinant of minus A inverse is equal to the determinant of, so to say, 1 by the determinant of A. Determinant of A inverse is 1 by the determinant of A, because of the reason that determinant of A inverse A is equal to 1. A inverse A is I, and A inverse or A inverse A, both are equal to, I, and determinant of I will be equal to 1. Therefore determinant of A inverse is equal to 1 by determinant of A, and that will give us the value 2. So that is the first part. The second part is, if it's a 3 by 3 matrix, again, when determinant of A is minus 1, find a determinant of half of A, determinant of minus A, determinant of A square, determinant of A inverse. Okay, so now determinant of half A is half to the power cube. Determinant of A is minus 1, and this is 1 by 8. 1 by 8 into minus 1 will give minus 1 by 8. Determinant of minus A is minus 1 to the power 3. So because now it's a 3 by 3 matrix, so therefore this will become minus 1, and this is minus 1. Minus 1 into minus 1 will become plus 1. Determinant of A square will be determinant of A whole square. Determinant of A is given minus 1. Minus 1 whole square will be 1. Determinant of A inverse is 1 by determinant of A. Determinant of A is minus 1. 1 by minus 1 will give minus 1. So thus we can get all the solutions over here like this. Okay, so now for each one of this, whether each one of which one is true or which one is false is what is written in the next solution. Okay, so that will be determinant of I plus A is 1 plus determinant of A. Is it true? Is the point, right? So determinant of I is always, determinant of I plus A. Need not be, you can't separate the plus. If it is a multiplication, might be you can separate, but plus you can't separate. That's why we see that this is not true. So determinant of I plus I is not 1 plus 1, except when n is equal to 1. Okay, but otherwise it is not true. So this is, we see that it is not true. You need to take a 2 by 2 example. I will be 1 0 0 1. A will be, might be, you can write 2 1 3 2, something like that, and try to add and find its determinant and whether it corresponds. Find this value. You will definitely see that it is not true. Okay, so you will see that it is definitely not true. So then determinant of A, B, C is determinant of A multiplied by determinant of B, and this is determinant of C. So this is really speaking true, because we see that we are just trying to extend the rule of 2 matrices to 3 matrices. That's all. We have considered here 2 matrices, determinant of A into determinant of A square is equal to determinant of A into determinant of A, and that is true also. Similarly, it is just a 3, so that is true. Then determinant of A to the power 4 is determinant of A whole to the power 4. This is very much true, because again we are just extending this rule to 4 variables and putting A equal to B equal to C equal to D. Okay, if I have 4 different matrices A, B, C, D, then determinant of A, B, C, D will be determinant of A into determinant of B into determinant of C into determinant of D. If A is equal to B is equal to C to D, then we'll have this only. Okay, so it is true. So then determinant of 4A is 4 determinant A. It is not true because determinant of 4A is 4 to the power n into determinant of A. Okay, n, 4 to the power n is there, and this is what is the formula. This is not the formula for that. So only for n equal to 1 might be it is true, but when n is equal to 2, 3, 4, 4, 5, it won't be true at all. Okay, it will not be true at all. So I might have made a mistake here. So this is rather D rather than C. This is what you call C. This is D. So it's a little shifted version. You know, so we need to correct this. This is D, not C. Fine. So this is another one. Let us not bother about what this is. We'll go forward. Okay. Which row exchanges show that these reverse identity matrices J3 and J4 have J equal to -1, but J equal to mod of J is equal to plus 1. Okay, so if you want to find this and you want to find this over here, exchange rows 1 and 3. You exchange rows 1 and 3 over here. If you exchange rows 1 and 3, then naturally it will be minus, determinant will become minus, and overall minus determinant, whatever is the one row exchange will convert it into the minus value. If you have a A as a matrix, if you exchange one of the rows, rather once you exchange the rows, then it will give you minus of that matrix, minus of the determinant of that matrix. Okay, so that's why if you exchange once, it will become minus. Okay, so that's why you will have J3 equal to -1. Determinant of 1, 0, 0, 0, 1, 0, 0, 0, 1 will give you 1, and but that should come with a minus sign. Okay, so that's why it is like this. Then we have exchanging row 1 and 4. We need to exchange 1 and 4. Then exchange 2 and 4. Twice exchange will be minus into minus. That will give plus. Again, you will get that the determinant of that particular matrix after 2 exchanges will give you +1. So +1 into +1 will give you the value +1 only. That's why it is J4 equal to 1. That is what we have here. Is it clear? I hope it is clear. Okay, by applying row operations to produce an upper triangular matrix, you compute the determinant of this and determinant of this. So you need to apply the row operations and find the upper echelon form, upper triangular U or upper echelon form. So that means you should make these as zeros. Okay, I don't know whether we have done the same thing. These as zeros. Again, here also we should make these as zeros. Somehow we should do the operations, different row operations we should do, so that these turns out to be 0. So if you do that, then it is just the multiplication of the diagonal matrices with the lower triangular part equal to 0. If the lower triangular part is equal to 0, whatever we have in the pivots, all that if you multiply, you'll get the value. Okay, so first determinant will be 36. The second determinant, I don't know why he has put difference here. The second determinant, second difference matrix, or I don't know what it means. Determinant will become 5, because if you multiply the pivots there after making these zeros, that will become 5. So it is for you to try. Okay, both these you please try. Then you have use row operations to simplify and compute their determinant. Same thing. Okay, you have to do the upper echelon form and find the determinant. In the same thing here also, upper echelon form and find the determinant. You will get this. Okay. Then Use row operations to show that a 3 by 3 Vandermonde determinant, which is given by this, turns out to be this. So solution is given here. So what we are trying to do is, again, we are trying to make the, upper echelon matrix equal to, 0. Really speaking, we need not do this. You can as well find the upper echelon form and multiply it by the, what you call, so to say, the pivots there. So the pivots there, I think, should become a b minus a into c minus a into c minus b if you try to do that. Okay, if you just try to do that, you will get that quantity there. Okay, so one more time, if you do the operation, and if this becomes, so to say 0, then you can just multiply all this, and then that will give us the value, which is something like this. Okay, he might have done by a little different method. Either you do this, but